I would like to go over a few things that I've discovered in the past few weeks, things that tend to support the GaaWF hypothesis. So I'd like to just go through them one at a time. The first one is HL Tauri. This is a system, a very young system that is in the stages of planetary formation. And the thing that's surprising about it is that it is separating into protoplanetary rings much faster than current theory would allow. Now, under GaaWF, you'd have both pushing and pulling going on, and these areas that are dark is where matter is being pushed out, where gravity is repulsive. And so when you have sections that are repulsive and sections that are attractive, this would explain why HL Tauri is separating and forming these rings much faster than current theory would allow. The next thing I'd like to share is this investigation of Bennu that NASA is doing. There's two aspects of Bennu that sort of support the GaaWF hypothesis. The first one is that under GaaWF, a planets and stars must be at certain set sizes. Um, there isn't like any upward max limit or anything, but they can only be at certain set sizes because you cannot have the surface of the planet or the star at a place where gravity would be repulsive. That would mean that the star or planet was unstable. And so with Bennu, they have a small asteroid that surprisingly is very geologically active. In other words, it seems to be kind of unstable, and it is also spitting out small rocks. Now, they have various attempts to try to explain this. None of them are particularly satisfying. Things like expansion and contraction causing um, little explosions would explain like a single event, but it's hard to believe that it would keep on happening like this. And so Bennu is kind of, I suspect, is a quantity of matter that is not stable. And so that's why it is not able to settle geologically, and it's geologically active, something at that size, which is very surprising. And of course, having a fountain of rocks keep shooting out of it is surprising. And I propose that it is repulsive gravity that is doing that. The next thing I'd like to take a look at is the Parker Solar Probe. There's two or three different things that they're finding in this Parker Solar Probe mission that are suggestive, I feel. The first thing is that some of the dust and ions and so forth that are orbiting the sun are doing so at speeds that are tremendously faster than current theory would allow. They can't understand how they can be orbiting at that speed. And of course, under GaaWF, there are certain gravitational peaks at certain distances, and so objects might be orbiting at speeds much faster than current theory would allow. Now, they're also finding peculiar rings in the sense that there'll be areas where there's just tons of dust in a zone, and then a layer where there's nothing. Okay, and this is also surprising. They're not really understanding why that is. And again, under GaaWF, there would be areas like that where the zones where there's nothing would be caused by repulsive gravity. Now, lastly, they have some pictures, or they had some pictures, or maybe you've seen them, of the switchbacks. And those, I'm not sure if they would be relevant to GaaWF or not. I'm not quite sure exactly what they are or what's causing them. But that's an issue that potentially might be explainable under GaaWF. The next thing I'd like to take a look at is Saturn's rings. As I explained in my last simulation, where I was simulating solar system formation. Please see that recording. I mentioned this where um, uh, in some of my simulations, the orbits took on kind of a braided appearance temporarily, and we see evidence of these braids in Saturn's rings. We can see places where we have kind of a wavy nature to the rings. And I propose it's because the objects there are um, kind of alternating back and forth between a repulsive and attractive region. And that's why we have this wavy sort of orbit. The last thing I would like to take a look at is this exoplanet. This is a planet discovered around a different solar system. It is GJ3512b. That's the name of the exoplanet. And it is too big for its star. They can't explain how, according to current planetary formation theory, how this planet could come to be formed. Now, under GaaWF, as I said, certain sizes for a sun would not be allowed. They would be unstable. And I am proposing that in this case of this system, uh, what happened is that the amount of dust and gas that was present to form this sun was not an appropriate amount to lend itself to stability. And so that which is excess would be expelled out. And I think that this is a very common thing in the universe, and that this is the explanation as to why most solar systems are binary. And I believe it is because in most solar systems, the amount of mass isn't perfect for forming a sun or a star. And so there's always going to be a certain amount of excess. If that excess is large enough, it will form another star, and the stars will be orbiting each other. And if the excess is not large enough, then it ends up forming various planets that are rotating around that star. And that's about it for today. Thank you very much for watching, and we'll see you again soon.